The last method that we will use to solve quadratic equations is by using the quadratic formula. The solutions in a quadratic equation in general form, ax squared plus bx plus c equals to 0, with x not equaling 0, are given by the quadratic formula. Again, we will use the form of ax squared plus bx plus c in order to find a, b, and c that we will use in the quadratic formula. You need to memorize this formula. X is equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a. We use the quadratic formula in a situation maybe where if you can't solve the quadratic equation by factoring, you can always put it in the form of everything on one side set equal to 0, find your a, your b, and your c, and use the quadratic formula to find solutions. So we use the quadratic formula when factoring does not work. We can always have an alternate route of the quadratic formula. Looking at this specific problem, 2x squared minus 6x plus 1 equals to 0. I see that everything is on one side set equal to 0. It must be in the form of ax squared plus bx plus c in order for you to pull down the values of what a is, what b is, and what c is. We can easily see that a is 2, b is negative 6, and c is 1. So those are the values that we will use to plug into the quadratic formula. A equals to 2, b equals to negative 6, and c equals to 1. So using the formula negative b, that will be negative times whatever b is, which is negative 6. Negative b plus or minus the square root of b squared. I'm going to put negative 6 in parentheses because you will always square whatever b is. And since b is negative 6, that's going to be like I'm going to say negative 6 times negative 6. Minus 4 times a, which is 2, times c, which is 1, all over 2 times a, which is 2. Continuing, negative times negative 6 gives me positive 6, plus or minus the square root. Negative 6 squared, that's negative 6 times negative 6 is positive 36. The next step is the difficult one. In the formula of negative 4ac, all of this is multiplied together. I'm going to say that again. Negative 4ac, this is all multiplied together. So, going back to my problem, I'm going to multiply all of this together. Negative 4 times 2 is negative 8 times 1 gives me negative 8. All over 2 times 2 is 4. Next, working under the radical, I have 6 plus or minus the square root. 36 minus 8, that would give me 28 divided by 4. Looking at my radical, I can't take the square root of 28. Think of your perfect squares. 4, 9, 16, 25. Will any of those numbers divide into 28, and what's the biggest one? Well, I can break 28 down to 4 times 7. The square root of 4 would come out as 2, and 7 staying under. So I have 6 plus or minus 2 on the square root of, times the square root of 7 over 4. If you can find a common factor between these three numbers, the 6, the 2, and the 4, you can reduce each one of these by that common factor. Well, I see that I can divide each one of these by 2. So I'm going to take out a 2. It's kind of like you take out a 2 out of the numerator. If you take out a 2 out of 6, it leaves me 3. If you take out a 2, if you divide this number by 2, it gives me 1 square root of 7 over 4. But what can you do with the 2 and the 4? You can reduce those. 2 divides into 2, 1. 2 divides into 4, 2. So I end up with 3 plus or minus the square root of 7 divided by 2. Again, I could have just taken out a 2 out of all 3 of these numbers. 6 divided by 2 was 3. 2 divided by 2, there's a 1 there, but it's understood. And 4 divided by 2 gives you 2. So we could write our final 2 answers as 3 plus square root of 7 divided by 2 and 3 minus the square root of 7 divided by 2. So there's your 2 final answers when you solve this quadratic equation using the quadratic formula. There's your 2 final answers, 3 plus the square root of 7 over 2 and 3 minus the square root of 7 over 2.